In this video, we're going to find the volume of the solid of revolution formed by revolving the region bounded by the function y equal the square root of x, the horizontal line y equal 1, and the vertical line x equals 0, which of course is the y-axis. And this region will be revolved about the x-axis. So let's look at the main setup here. Last time we did one involving the shell method. And when you use the shell method, the representative rectangular strip is parallel to the axis of revolution. Today we're going to use the disk method. In this case, the rectangular strip is perpendicular to the axis of revolution. So for the first one here, if the axis of revolution is horizontal, then the volume of the solid of revolution is given by this formula here, pi. And of course the volume of the disk is pi r squared times the height. So here we have a to b pi r squared x minus r squared x. We could break this up into two integrals. R is the outer radius and r is the inner one. Now it could be that r is 0 if the region is right on the axis of revolution, there's no hole. But that's your main setup there for that one. Now if the axis of revolution is vertical, then the volume of the solid of revolution is given by this setup. Pretty much the same thing, except instead of r of x, it's r of y. And this is an example here of what we look like. So let's say we have this region, we have a rectangular strip, and we're rotating about this axis right here. So the r goes from the axis of revolution up to that point right there on the curve. And then the inner radius is this one right here, this distance. And r, again, is from the axis to the end of the strip. And the width is the dx, of course, and that dictates the variable of integration. Now, if you have it the other way, if you're rotating against a vertical axis, it will be this way. And the width of this strip will be dy. So the integral of integration would be the y variable, or dy. Go back then to what we have here. So this is the line y equal to 1 here. And this x equals 0 is, of course, the y-axis. And it's this region right here that we're going to revolve about the x-axis here. So if I take a typical, a representative rectangle, I would just draw it this way. Again, for the disk method, the representative rectangular strip is always perpendicular to the axis of revolution. So this would be your dx here. And from the axis to that end right there, end of the region there, that's going to be 1. And then this distance right here, that's the r, small r. That's going to be y, or the square root of x. So I plug those into that formula, and of course the interval again, because it's dx, it's along the x-axis. So it's going to go from 0 to 1. So you're set up, and it's going to go like this. The interval of integration will be 0 to 1, and this 1 again is the distance from the axis to that line. That's your big R, outer radius. And this, of course, is a small r. So you're subtracting the two volumes. So in this case, there's going to be a hole. Now notice if I were to rotate this curve about the x-axis, say I wanted this curve right here. Say I wanted this. If I wanted to rotate this about the x-axis, in that particular case, capital R would be this distance here for the length of the strip, which would be the square root of x, and the small r would be 0, because the boundary is on the x-axis. So once you've set it up, it's just a matter of doing the integration. So this is equal to pi integral from 0 to 1, and then 1 squared is 1 minus radical x squared is x dx. Now it's the easy part, or it's supposed to be. Once you've set up the formula, or the integral for the formula of the volume of revolution, the rest should be the easy part. And especially in this case, because you have a first degree expression here. We integrate with respect to x. So integral of 1 with respect to x is x. Integral of x squared with respect to x is x squared over 2. Just a power rule, add 1 to the exponent, divide, you get this, and then evaluate from 0 to 1. So this will equal to pi and evaluate at 1. So this will be 1 minus 1/2 and then we evaluate it at 0, so that's just going to be minus 0. So we have 1 minus 1/2 is 1/2 minus 0 is still 1/2 times pi. So we get the volume of revolution of that particular solid generated from that region is pi over 2. And that's cubic. Since its volume is cubic units, doesn't give the actual units, so we just say pi over 2 cubic units. Thanks for watching. We'll see you next time.